Okay, so this is going to be the law of sines and the law of cosines. And the law of sines is the easier one to manage, so whenever you can use it, I would use it. The law of sines relates the ratios of, we have sine big A over little a equals sine big B over little b equals sine big C over little c, where B is opposite B and A is opposite A and C is opposite C, like that. You can also turn these upside down. Basically, if you're trying to solve for an angle, you should use this kind. And if you're trying to solve for an angle, use side, use this one. You can use either one for either thing, but you will end up having to get something out of a denominator if you like need to solve for an angle and you use the second version, because your angle will be in the denominator. Your sine of your angle will be. So you'll have to get it out of there, which is just a little bit of an annoyance. So I just would not do it that way. Okay, so for example, we have capital A is 30 and B is 70 and little a is 8. We want to find little c. So the partners that we have are A and A, and we want C, so we're going to have little a over sine A equal little c over sine C as our goal, because we're trying to solve for a side, so we should put the side in the numerator. Okay, when you have two angles, you have the third angle for free because they add up to 180. So C is 180 minus the ones we've already got. So C is 80 degrees. So 8 over sine 30 equals C over sine 80, which means sine 80 times 8 over sine 30 is little c. I don't have a calculator on this computer, so I'm just going to use Desmos. So 16. The reason I say 16 and not 15.8 is just because we seem to have two significant digits as given us by the 8.0. So that's what that was left over from before. Okay, now we have a word problem. So we have an observation booth, and we're measuring shot put length. And one key thing is, even if they throw it from over there, the measure that for which they get credit is just from the edge here. That's their fault for not knowing how much to run first. Okay, so this is what it looks like. It's a tilted triangle. We have a device placed at A where the little dent was in the ground, and it sent a signal to the booth. And the distance from the booth to here is known ahead of time. And so that is already set. It's 562 feet. And they get the measure of angles A and B from the little device. Okay, so we have A equals 562, B equals 5.7, and A equals 85.3, and we want to know what did they throw. So we've got 562, 5.7 degrees, 85.3 degrees, and we want this value here. We could find this angle, but who cares, right? Because we have partners here and we have our partner over there. So we're looking for a side, so put it with the sign on the bottom. And we've got A over sine A equals B, which is x, okay, over sine of B, which means sine 5.7 degrees times 562 over sine of 85.3 degrees is x. So 56, it looks like. The law of cosines is more complicated, except that the Pythagorean theorem is actually a special case of it, so you can kind of relate it to the Pythagorean theorem, and it's not so bad. This first one looks, well, the third one looks the most like the Pythagorean theorem. C squared equals a squared plus b squared minus 2ab cosine c. In the case of Pythagoras, c is the hypotenuse, so capital C is 90 degrees. Cosine of 90 degrees is 0, so that whole thing becomes 0 and disappears. Okay, but you can remember it using Pythagoras. So what happens is that the letter that's on the left is the same as the letter angle that's on the right. So A goes with A, B goes with B, C goes with C. If little a is on the left, it will not be on the right. So the b squared plus c squared, I think you can remember, and then minus 2bc cosine A. So they both appear there. You don't have to figure out which one goes where. If you have all three sides, you can sort of just solve for whatever angle you want. If you want to solve for b, then put little b squared on one side. If you only have one angle in your problem, then you don't have a choice. If the angle you have is A, you have to use the first one. And if the angle you have is B, you have to use the second one. If the angle you have is C, you have to use the third one. Okay, so this is a little argument of why using the Pythagorean theorem, that feels a little funny because I said the Pythagorean theorem is a special case of this, but he didn't know about this when he came up with the Pythagorean theorem. So he didn't, lean on it at all. So essentially we drop an altitude and we call it h. And then we have this whole thing as c, so we've got some little portion of it x, and then the rest of it c minus x. So on the one hand, a squared is h squared plus c minus x squared, which then gets FOILed out here. And then on the other hand, h squared plus x squared is b squared from this little triangle, so h squared is b squared minus x squared. So this is c squared minus 2cx plus x squared plus h squared, b squared minus x squared. So those go. And x, cosine of A is x over h, right? So this is kind of 2c. I'm messing this up. We have the plus b squared minus 2cx. And then, so cosine of A is not x over h. That was dumb. That's cotangent. Is adjacent over hypotenuse is x over b. So b cosine A is x. So this is c squared minus 2c b cosine A plus b squared. And then we write it in a less crazy way here. Okay, so this, for example, we have capital A, but we don't have little a. So to use the law of sines, we have to have at least one partnership where we have a capital and lowercase of the same letter. And we don't. We have big A and little b and little c. But because we only have one angle, our only option is the one that has cosine A over here and a squared over there. We don't have any choices. So this is b squared plus c squared minus 2bc. A squared equals 25 squared plus 32 squared minus 2 times 25 times 32 times cosine of 60. Cosine of 60 is 1/2. We could do this, because it's a video, I won't waste your time with me doing it by hand like I normally do. 25 squared plus 32 squared minus 2 times 32 times 25 times cos 60. The only reason we had a chance of doing it by hand is because that was a half. Even if it had been root 3 over 2, we would have been a little hosed. And then, so it looks like A is 29. Okay, inches. At this point, you could use law of cosines again. You have all three sides. So you could use law of cosines to solve for any of the other angles, because in the law of cosines, you've got side, 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 angle, right? So if you have all three sides, you can solve for whatever angle you want. But we have an angle. So I personally would use law of cosines to now solve for C or B. Okay, so I'm going to do, let's see, A was 60. I've kind of forgotten what everything was. And little a is 29. We're looking for, let's say we're looking for B. And little b was 25. This means sine B is 25 sine 60 over 29. So we use sine inverse. B is at least kind of equal to, it's the reference angle related to this. I'm just going to delete that stuff so I can see. Okay. Sine inverse of 25 sine 60 over 29. And I get 48. Okay, now as a side note, I know we haven't done multiple angles yet, that's 7.3, but let's just come over here and say, okay, it's either 48 or it's over here and it has a reference angle of 48. If it has a reference angle of 48, then we've got 132. If I said, okay, well, maybe B's 132, the problem is that A plus B is 60 plus 132 is 192 is more than a triangle. So in this case, there's only one triangle as an answer. And again, I know we haven't yet done that, but when that comes up later, because most of you are going to watch this after you already heard me talk about this and ask this question, somebody asked this question. So you can just give it a go and then go, oh, that doesn't work. So B must be 48. And when you go to solve for C in this similar fashion, really, C is 180 minus 48 plus 60, so 72. And now that's the whole triangle. Okay, I have added some here at the end. They're all in the lab, but the teamwork. But it was the quickest way for me to get some decent examples. Because I have A equals 6, C equals 8, and B equals 112, I have exactly one angle, and I don't have its partner. So I would have to use law of cosines. And because the angle I have is B, I've got cosine B over here and B squared over there. So B squared equals okay, 136. So 12. Once you have B, you can use the law of sines to solve for capital A or capital C by doing, say, sine A over 6, sine 112 over 12, multiplying through by 6. This is sine 112 over 2 after you reduce it. So we sine inverse that. And we get 28. And again, you can check it. It's 28 over here. Then the other one is 152. And 152 and 112 certainly can't be in the same triangle. So capital B is 180 minus and I'm assuming that's how they rounded. I don't have the multiple choices. It'd be something close to that, but it's possible they didn't round B to a whole number. I'm not sure. If you have all three sides, solve for whatever angle you want. So just pick your favorite. Maybe you just like A. So 7 squared. My voice is getting a little messed up, so that's why I'm not saying as much as I normally would. So 49 minus 169 minus 225. And then all of that divided by negative 390. So cosine A is 0.885. Do cosine inverse. And we get 28 degrees probably. Once you have that, use the law of sines to get the rest, so that you have sine 28 over 7 equals sine b over 13, and solve from there. Okay, so someone is flying 79 miles from Champaign to Peoria, and they get 10% off, 10 degrees off right away. It doesn't really matter which way. It doesn't tell you which direction, but when it asks you later, there's no west or east indication. So they get 10 degrees off. And they maintain the average speed of 84 miles per hour for 15 minutes. So basically, we take our 84 miles per hour times 15 minutes, which there are 60 minutes in 1 hour. And what we end up with is 21 miles they've gone. And somebody tells them, oh, oops. So here's their heading. And they turn around and head correctly now. The question is, through what angle will the plane move, which is this angle here. So we're going to find this one, and then we're just going to subtract it from 180. And how far do they go? So we want this. Okay. So right now we have two sides and an angle, and none of them are partners. This side's angle is not there. This side's angle is not there. So we're going to have to use law of cosines. So we have, let's call this A. And x is little a. So x squared equals 79 squared plus 21 squared minus 2 times 79 times 21 cosine 10 degrees. Bad things are happening. 79 plus 441 minus 2 times 21 times 79 cos 10, 3414.4 square root so 58.43 miles. And then how much did he correct? So we need this angle here. We've got a partnership now, a single partnership, and we want an angle, so we're going to do sine of B over B minus sine of A over A. So sine B equals 79 sine of 10 over 58.43. Okay, so sine of B is 0.235. So we're going to do sine inverse of B. Sorry, no. Sine inverse of this mess. And we get 13.6 degrees. And actually, let's see. Yeah, I think on your multiple choice they put 13.6, but really if the plane's heading this way, the amount they turn should be what's left of that. Oh wait, I get it. Okay, so let's look at the picture. Yikes. Come on now. Oh, I guess those are old. Um, so we know that sine of b is 0.235, but if b were 13.6, look here, would be going back this way. And if we did that, then this would have to be shorter than 21. So in this case, it's not the one we get, it's the reference angle guy. So here's 13.6 degrees. And then over here, 13.6 degrees. This all goes to 166.4 degrees. Okay, so this one is 166.4, leaving this part over here because they add up to 180, and that's how we found the 166.4 is by subtracting 13.6 from 380. That is 13.6. And the way that you know that is that you can't, if you're going only 10 degrees off, when you turn around, you can't turn in a less than 90-degree fashion, right? You can't turn backward. He didn't pass the place. So he went this way. He only went 21 miles, so he didn't pass it. So it has to be an obtuse angle. If you know it has to be an obtuse angle, then you know that you have to use what you get from sine inverse as a reference angle and then go figure out the angle from there.